Hi, so I've got a model for you that I'd like to present. It's a landing gear of a RC plane model. So what you see actually is an on-shape assembly, fully defined. So we started with creating all the parts and then assembling it together to a on-shape assembly. You can also see that it is working with having all the kinematics defined. But when it comes to compute some motion due to forces or some complex motion with several degrees of freedom that are actuated, then one will have to change the way of work, or in other words, you will have to go to another app. And this, for on-shape, is Principia. So in Principia, we import all the details from this landing gear, so from the on-shape assembly, all the parts, all the interfaces, also all the constraints, the joints between the bodies. So you can see them here. They are all imported with all the inertias, with all the details for the constraints, so positions, orientations and stuff. And then one can load the system additionally with forces. In my case here, I have a contact. So contact between those two bodies, which is defined below this force element. Then I have a cylinder, you see it here, and another damper that is located here. So in our app you can define all these loads, then you can define sensors. So if you want to equip your system with sensors, you can do this here. So for measure positions, angles, velocities, etc. And then in the settings tab, you can define all the simulation settings like time stepping, like the length of the simulation and the environment you're in. So probably you are on Earth, and that's why you have to define the gravity. With hitting the Start Simulation button, you can trigger the simulation run in the cloud. You can monitor the simulation progress in the History tab. You see it here. So we have 100%, and then we should be able to monitor or to see the animation of our motion. So the system is actuated to my hydraulic cylinder and then dampened, and also this contact element comes into play. Now what you can do with the results, the one thing is you can monitor if the function is correct. So you see it is in the right position in the end. You can monitor that there is no collision between parts. What else can you do is you can see if your actuators or your interface forces are below a certain limit. So think about some retract cylinder. We see in this case it was defined like it has a force of maximal 100 Newton, and in this case we exceeded the force, or it would have exceeded if we haven't limited it. So that's why we are in these force limits of 100 Newton. So what we can observe here is this cylinder is probably too weak and we have to go for another one. And the third thing we can do, we can observe excessive loads and can define them as load cases, for example, for finite element analysis. So in my ball joint here, which is an interface somewhere in my system, I see that there is a peak load exactly in this position, and I can say I'd like to export these force values to an on-shape variable studio, and with having this data in the on-shape variable studio, one can use it for detailed finite element analysis without even copy and pasting any value at any time. So that's basically it. So we have 3 fields of application: check the functionality with animation, for example, then the dimensioning of any parts, of any standard part, of any component of your system, with just using forces or other parameters. And the third thing is exporting detailed data to, for example, finite element analysis. So that's basically it. Thanks for your interest.